All right. Okay, so there we have the intermolecular force, the hydrogen bonding that you find with the hydroxyl functional group that you find with the alkanol or alcohol homologous series. Okay, so it's this part that is polar, that can dissolve with water, that is polar. And it's this side that is non-polar, that can dissolve your fats and your oils on your skin. That is non-polar. Okay, so that is what is explained here. Then I'm just going to say again, the hydrogen bond that we find there, the hydrogen bond intermolecular force there, makes it a strong intermolecular force, causing it to have a higher melting and boiling point. Then alkanols burn in air to give you carbon dioxide and water. So if you burn alcohol, it gives off carbon dioxide and water. And then what do we use it for? We use it as in fuels. We use it for alcoholic beverages. Have you ever heard of glycerol? Glycerol? Have you ever heard of glycerine? Where do you find glycerine? In lotion, in Vaseline. Someone has Vaseline with them? Yes. But the most common one everyone knows is Vaseline.
Yes, ma'am.
Okay, read at the back. What does it say? What's the ingredients?
It's not Vaseline.
No, man, it has glycerol. Glycerol?
It's international as well. Yeah, man. Import. 2009.
Okay, ingredients, petroleum. Petroleum is glycerol. And then here's benzyl alcohol in eugenol, urinol. So there's lots of oils in. All tells you glycerol, it is an alcohol. So we also use it in pharmaceutical, so in beauty products, as a moisturizer. Pharmaceutical. All right, just FYI. So Vaseline. What Vaseline? So you'll never see me use Vaseline on my lips or on my skin, because Vaseline, what it does is it creates a barrier, okay, between your skin and the outside. And then your skin cannot absorb the moisture and the air from air. So when you take off the Vaseline, your skin is drier than it was before. So that is why I don't use it, because it doesn't actually moisturize my skin, it just blocks it. So that it doesn't. And now I use olive oil. Olive oil. Yes. Okay, right. My family farms with olives and olive oil, so for me it's easy.
Do you also sometimes drink Vaseline
Yes.
with olive oil?
I have olive oil cream. Okay, right. So let's quickly look at the structural formula for a sweetie. What is the structural formula? Not the definition. No. What is it? Not the definition. Just explain to me in your own words. What is a structural formula?
The structural formula.
It's when you break down the formula into
CN.
Ma'am, this is all the formula to your componentation.
That's a general formula. What is a structural formula? I said it's where you show. That is my sweetie.
Double bond.
Where you show each and every bond. That is a structural formula. All right. Methanol. Meth means one. So we have one carbon. Then if we see the ol, the suffix ol, it means it belongs to the alcohol homologous series. So it means I must have a hydroxyl functional group. And then I say, all right, I have my H, I have my O. I must have 4 hydrogens. There's 1 hydrogen. Then I have 4 other hydrogens left. Okay, ethanol, eth means 2. 1, 2. And the ol tells me that it's part of the alcohol homology series, so it has a hydroxyl functional group. I'm going to be funny and I'm going to draw mine on the left hand side, just to show you that it can be written there. You can draw yours on the right hand side, you can draw yours at the top, you can draw yours at the bottom. It doesn't matter.
So then does coconut oil also have
It depends what it's mixed with. If you have pure coconut oil, I don't think it has. I have it at home, I'll check.
that is also good for skin.
Yes. All right, next one, propan 1-ol. Pro means 3. So we have 1, 2, 3, and it tells you on the first carbon you have a ol. Where's my first carbon, right or left? Doesn't matter. Okay, I see someone pointing to the right, so let's say to the right, but it can be to the left as well. Propan 2-ol. Cap off. Off. 1, 2. It's just us in class. What are we going to do? They know you. These people know you like the palm of their hand. They've been with you in class every day. Yeah, but you in the class, you look like that today. So take off your cap. Okay. Propan 2-ol tells you on the second carbon, there's a ol. So on the second carbon, I have a ol. Okay, then the next one, butan 1-ol. But means 4. 1-ol tells you on the first carbon you have a hydroxyl group. And butan 2-ol tells you on the second carbon you have a hydroxyl group. Can you get something like butan 3-ol? No. All right, then for 3 sweeties. Please explain to me, put up your hand, why, it's going to wait until I'm writing now. Please explain to me if we compare, let's say we compare butan 1-ol to butan 2-ol, and we look at their boiling points. Why does butan 2-ol have a lower boiling point than butan 1-ol? I've explained it a bit previously. No.
Come again.
Okay, wait. The longer chain thing. So longer chain is meth-pro-but. If I compare these 4, then you see the longer the chain becomes, the higher the melting point or the boiling point. But I want to compare these 2. They're the same length, 4-4. Same molecular formula. But the boiling point differs. Why? That is 1, sweetie. Okay? So if you look here the hydroxyl group is at the end. It is open. Okay, so another molecule can easily come here and can form an intermolecular force there. But this one here is surrounded by other molecules. If we had to go draw it, then you would have carbon, 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 hydrogen, 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 and then your O, and then your H. Okay, so it's very difficult for something to come in there and make a connection, not a connection, make an intermolecular force there. So because this one is more shielded by other atoms, the chances that an intermolecular force will form is lower, so it will easily be broken. If it forms, it will easily be broken. That's why the melting or the boiling point is lower. Okay, right. So I'm just going to make a note here. So for that one there, the hydroxyl is shielded by surrounding atoms. Thus, intermolecular forces are weaker. And then what's that golden sentence for a sweetie? What's that golden sentence? If weak intermolecular forces, thus, put up your hand. Thus, near a sentence, not a word. Yes. Thus,
It will be
No. If the intermolecular forces are weaker, then no.
Where is it? Via something to overcome something. To overcome. How much is it?
Repelo? Ooh! Yo!
When I get one switch for seeing.
No. You don't get a mark for saying something overcome. Okay, so thus intermolecular forces are weaker, thus less energy will be needed to overcome the intermolecular forces between molecules. You said this a million times last year. Thus, less energy needed or required, whatever, needed to overcome intermolecular forces between molecules. Okay. I'm just testing. Kom. I'm not born yesterday. I wasn't born yesterday. Is jy klaar geskryf? Because I want to page. What? Oh, a speed test.
Let me check them.
Huh? No, it was just break. Alright. So, let's go on to the next page. Going, gone. Alright, now it goes on. It says, alkanols can be oxidized. Okay, now the word oxidized means to react with oxygen, or in your head, it's not formal, but or to make oxygen more prominent. What does the word prominent mean for a sweetie? To make oxygen more prominent. I am a prominent feature in your life.
Important. Like inspirational.
Okay, what did you say? You said?
Prominent makes it
Like man, you are active inspirational.
more like a key thing.
I love the compliments that I'm getting. That is nice.
Key.
Yeah, but you can't answer. You have too many sweeties.
To highlight.
All right. So prominent means to highlight or something that you see often. Okay. So prominent. So what I mean here is either it reacts with oxygen or so that oxygen is more highlighted. Oxygen you see more. Okay. Right. So it says there, alkanols can be oxidized, can undergo reaction to form aldehydes and then carboxylic acids by a strong oxidizing agent for a sweetie.
Huh?
Two sweeties. Give me the name of this or this. And for a bonus sweetie, if you can give me the color.
Yellow.
That Lego, don't shout out and it's not yellow.
The KMNO4 zinc potassium
I'll give you sweetie. Potassium permanganate. Potassium permanganate. Color? We used it in the practical last year.
Blue.
No.
Whitish. Yellow. White.
Purple. The next one. The next one. Potassium. What?
Potassium.
Yes?
Chlorine.
No? There is a CR there. It's number 24.
That's what I said. I said chlorine.
But it's not that. I want the name.
Potassium chromate
Chlorine.
oxide.
Potassium. Potassium chromate. Potassium chromate. And the color? No?
Is it black?
No? No? Put up your hand and no, no, no. No?
Silver.
No? Yeah.
White.
No?
Whitish.
No?
I want this guessing.
You are. Then you write this down. Potassium permanganate, potassium chromate, purple and orange. Here, you guys. Say again? No, yesterday when I bought these sweets, I thought, what am I doing with you? I'm teaching you bad habits by telling you there's a reward for silly things.
And ma'am, and the thing is now we're doing it in class.
Not every class.
Are you doing it in?
Every class.
Which every class?
You get sweets.
I did all sweets. I also did them. If we get full of for the taste, what are we doing?
See, it's not a good thing that I'm starting. I must stop. I think I'll stop. I'll just eat it by myself. Alright, so these things are called, they are oxidizing agents. They are actually like a catalyst. Okay, so they don't take part in the reaction, they just help the reaction. So they are catalysts. Okay, so if we look at this reaction here. Okay. So here I have ethanol, as you can see, I have ethanol, A2O, ethanol. Then when it undergoes oxidation, the first step is 2 hydrogens are removed. So it removes those 2 hydrogens, and those electrons that are unbonded, they come together and they form a double bond there. Okay, so it goes from this to this. As you can see here, this is an aldehyde. How do you see it's an aldehyde? There. It is a carbonyl functional group that is part of the aldehydes. Aldehyde, you see, is anal. Do you see the anal there? Ethanol, it means it's at the end. Aldehyde. Then it can undergo oxidization even further. Then you add the oxygen, and then you can see it forms a functional group of a carboxylic acid. So that there is the carboxyl functional group. It is an carboxylic acid, a carboxylic acid, so it's part of the carboxyl functional groups. So carboxylic acid, and that name there will be ethanoic acid, because it has 2 carbons, ethanoic acid. Alright, now this is a very good example of what happens when you leave alcohol open. Okay, now none of you have ever drank a drop of alcohol in your life, but I'm going to explain to you what happens if you do. Okay, you've never drank alcohol in your life. Yes? No, you. Yes, I'm correct. You haven't. Okay, yeah. All right. So I'm going to explain in terms of wine because I also come from a wine farm. So I grew up in the Western Cape where we don't drink beer, we drink wine. Okay, right. So what happens when you drink wine is when you are very fancy, you don't just open your bottle of wine and you drink it immediately. Then you know it's bad wine. Okay? So normally if you have a good bottle of wine and you invite someone over for it, to drink some wine or for supper and you drink wine, you open the bottle about half an hour earlier. Yeah, wait. That is good manners. Because if you do, it oxidizes, it reacts with oxygen. Not all the molecules, but some of the molecules on the surface. And when you do that, it becomes oxidized, it becomes an aldehyde. And an aldehyde gives nice flavors as well. Okay, right. So then when you smell the wine, you're like, oh wow, this wine smells very nice. Now you drink the wine, you don't drink all of it because you're not a drunkard. You don't drink all of it, you drink 1 glass, 2 glasses each. Then there's a little bit of wine left. Okay, you go to bed. The next morning, you think, oh, the wine was so nice last night because I opened it a half an hour earlier. It was very good. And now you want to drink a gallop of that wine. Flavor is not gone. It is bitter because it has oxidized even further to ethanoic acid. Ethanoic acid is vinegar. So if you leave wine or alcohol open for too long, the first bit is good, half an hour, it's good. If you leave it open for too long, then it becomes an acid, then it becomes vinegar. That's why have you ever experienced or seen it? If you leave it open for too long, even beer or hard alcohol, whatever, if you leave it open for too long, then it becomes bitter, it kind of goes off. You must not drink that, it is not good.
Is it where the part where they're aging?
No, so the aging, there's a bit of oxidization that goes on there, but aging it's closed. It doesn't react with oxygen. If it reacts too much, then it's not good. Alright, so what you must remember here is an alcohol can oxidize. The first step, it goes to an aldehyde, which is nice. And the second step, it goes into carboxylic acid, an acid which is not good. Yes? Is it about a sweetie? Okay.
Let's see. Buy myself a Jägermeister. And it's open.
You know what it must be?
When I drink it, I'm gonna be more drunk.
No, not more drunk, no. The content of alcohol will remain more or less the same. You won't become more drunk.
Then you open and drink.
So man, it goes the same with whiskey and vodka and all those.
Yeah. So, but those things, the alcohol content is a lot higher. So all the alcohol does not oxidize, so you can leave it open for longer.
And then it won't taste bitter.
No. So whiskey you can leave open for, I think, 4 months or something.
Okay, like not cruising.
Well, no, like open and close it again. About 4 months, 6 months. All right. Listen, I don't drink a lot at all. So my advice regarding alcohol is very limited. I do occasionally drink something, but
That's the answer you want.
no, guys. And when I drink a half a glass of wine. No, but I promise, guys, it is. Wait.